All right, so you guys probably remember our entry task from last year. I'm going to try and incorporate the same thing into the videos this year. So find the point of intersection for these two systems of equations. At what point do they intersect? You guys go ahead and try it. All right, so we're trying to solve each system of equations. And there's two ways to do it. One method that we learned probably back in Algebra 3-4 was elimination. And what we do is we look at this and we try and see what would it take to get these coefficients to be opposite each other, or these ones. Some people might look at this and say the common multiple is 10. Since these are already opposite in sign, that's the route I'm going to go. And somebody else might look at this and say, well, I could multiply this by a -2 and get -4x and +4x. So you just have to pick one. The only thing is when you multiply by a negative number, it's always easy to make mistakes. So you just got to be real careful if you do that. So if I multiply this by a -2, what I'm going to get is a -4x plus 10y, and that would equal a +28. And so now what I'm going to do is I'm going to add these two equations together. Those two will eliminate each other. Add here you get 12y, add here you get 48. Divide by 12, we get y is equal to 4. And so now we just plug it back into either one of those to find the x value. So let's see, I'll go ahead and, since everything's positive here, I'm going to go with this equation. So 4x plus 2 times 4, that's 8, equals 20. And so if I subtract 8 from both sides, I get 4x equals 12. Therefore, x equals 3. So my answer is 3, 4. I want to make sure I give that as a coordinate point because it's the point where these two lines would intersect. All right, the other method we learned would be substitution. And substitution works really well when you've got one variable that's by itself. And I could do that for x or I could do it for y. So I'm going to take this equation. I'm going to move this 5x to the other side so it becomes negative. So I've got 6 minus 5x. And now I'm going to take that and substitute it back in for y, into the first equation. So now what I have is x minus 7 times 6 minus 5x equals 30. If I distribute that, I get x minus 42. Negative times a negative, that's a positive 35x, and that equals 30. And so now if I add these two together, I would get 36x. If I move this negative 42 to the other side and do the opposite, I would add that, I get 72. Divide by 36, we get x equals 2. And so when I plug it back in, I want to plug it into the one that has y by itself, because that's the one I'm solving for next, right? So I'll plug a 2 in for x and get 10 plus y equals 6. We'll move that to the other side and subtract it, and we get y equals a -4. So 2, -4. Sometimes I see people do this. 2, -4, there's my answer. That's not a point, right? That's not a coordinate on the coordinate system. When we write down an ordered pair, we got to make sure we put parentheses in there. This is the proper way to write this. This is us being kind of on the lazy side, not wanting to write everything down. Although I look at that and go, lazy? How hard is it to write 2 parentheses? You know, it's not very hard. So make sure that we're writing our points the way that we should. All right, so here's another system of equations that we need to solve. But right away you notice something a little bit different about this. It's not 2 lines, it's a parabola and a line. And if we think about that, if I got a parabola and a line that goes through there, I might be looking for 2 possible points of intersection. Or maybe this line sits a little bit lower and it only intersects at 1 point. Or maybe it sits down even lower and they don't intersect at all. So we could be looking anywhere from no possible solutions to up to 2 solutions on this. So I don't think I would use elimination here. I think I would probably try and use substitution. I want to take these two equations and get this in terms of just one variable and then try and solve that. You guys go ahead and give it a shot. All right, so if I was going to solve this, I think what I would do is I would probably solve both of these for y and then set them equal to each other. Or just solve one for y and substitute in. So this equation, if I move the y to the other side, and I'll bring the 3 back over here and subtract it, there I've got y by itself. I'll do the same thing here. Bring the 1 back over. And so now, if both of these are equal to y, then that means these have to be equal to each other, right? So I'm now going to say that x squared minus 3 is equal to x minus 1. Since I've got something with a variable, I need to set the whole thing equal to 0 and see if I can factor and solve that way. So x squared, if I bring this over, it becomes negative. Bring this 1 over and add it, I get minus 2. And now I need to see if I can factor that. So it looks like if I had x minus 2 and x plus 1, that would work. X squared would give me that term. X minus 2x would give me that term. And a negative 2 times 1, that would give me that right there. All right, so we know that x equals either 2 or negative 1. And so now what we need to do is we need to plug those numbers back into either one of these to get my y-coordinates. This one looks like the easier one. As a matter of fact, I'll plug into this right here. If x equals 2, 2 minus 1 is 1, and so I've got 2 comma 1 as one solution. And if I plug in a negative 1, negative 1 minus 1, that's negative 2, there's my other solution. So how could I check this to see if I've done everything right? And I realize you guys, I thought the answers were in the back of that PDF book that I gave you guys. I realize they're not. So we may be switching books sooner than I anticipated. But I believe this is the kind of answer we can check. If we went to our graphing calculator and I graphed this, and then double check to see if that's where they cross, I could probably just look at the graph. I don't even have to calculate the point of intersection. If those are the 2 points I see, well then I know that I've done things right. All right, so one of the things I'm going to have to do this year that's a little bit different is I'm going to have to pick and choose what's really important. When we're not right here face to face, it makes it a little more difficult to get information out to you guys and make sure I'm really teaching you so that you understand. So anything that I come across that I kind of look at and think, this is just extra stuff that we don't really have to do, it's not on the central test, if it seems like it's going to be a burden, I'm probably going to skip that. And we have a little bit here with this section. The other thing that we would normally do is, I don't know if you guys remember, we'd enter data into our TID4 and we would do a linear regression or a quadratic regression or possibly an exponential regression. We've got some of that stuff that we would do, but it's not easier on a TID9. It's a lot more difficult. This is one of those times where I'd rather throw the TI-89 and go back to my TID4 and use that. So I'm going to skip that stuff. So our assignment for today really is just, it's number 1 continued. We haven't turned it in yet, so we're going to keep on calling it number 1 until we do. Just page 8, we'll do 61 to 68, and they're all similar to the problems that we just did, solving systems of equations or finding points of intersection. All right, that's what we have for today. You guys take care.